I'm going to tell you the story about our company. Our company is Ocean Energy Limited. Okay, we're going. Ocean Energy Limited came to life back in around 2000 when its founders, two gentlemen by the name of John McCarthy and Michael Whelan, were looking at this new prospect of wave energy and what it might offer. And they were looking at the available technologies that were out there at the time. And one of the ones that appealed to them was the concept of oscillating water column technology, which you will know has been around for quite a number of years. But the vision and the plan that the two guys had was to take oscillating water column technology and to make it float, and not just to make it float, to make it efficient in terms of its power delivery. And there were a number of principal points that were looked at and have been adhered to over the duration of our experience so far. It was a simple design and ease of construction with only one moving part, low mooring forces to try and improve the survivability of the device, bearing in mind we're working in incredibly harsh ocean-based environments. We needed something that was going to be low maintenance in terms of O&M. After all, if you've got something offshore at the scale that these devices are working, it's not easy in terms of work either on board or retraction back to shore. And of course, you needed a means by which you could plug and unplug in terms of power delivery. In terms of how the technology works, this animation, I hope, will explain.
The device effectively looks like an L on its side, with the short part visible above water. As the water enters the open chamber, it forces the air upwards. The force of this air turns a turbine, which in turn generates electricity. When the water recedes, it creates a vacuum, and air rushes in from outside to fill it, and the turbine continues to turn in the same direction. It's this continuous motion of water and air which produces electricity.
So in simple terms, that's an analysis of and an explanation of how this technology works. We have a plenum chamber, we have airflow in two directions, the inward direction when it comes into the chamber and then the retraction in the vacuum when it retreats. We have a very close affiliation with Galway with this area. We spent over 2.5 years here on the Galway Bay test site with our quarter-scale model representative of full-scale Atlantic Ocean conditions. It was a significant experience for us because it was finally going to be the litmus test in terms of this device and its capability of working offshore. One thing that we needed to be very mindful of is this company has been privately funded since its inception, and as a consequence we made very strong, stringent demands of our technology as we reached various review points over the course of the technology development. And really we wanted a device when it went offshore in Galway, we wanted something immediately that was going to be sympathetic in terms of its sea environment. It was, and we needed something that again had the capability to survive. Very often the difficulty that we have with this sector generally is that those incidences of failures have been high profile, they have been unfortunate, and they are most unfortunate for the industry because we need every success story that we can get our hands on in this particular industry, given its continued early stages as it moves towards maturity. So after 2.5 years of testing in Galway Bay, what did we finish up with? We had proved our ability to survive in an incredibly harsh environment. We had full-scale energy output in terms scaled up, with our scaled-up device estimated to produce enough power for the requirements of about 1,500 homes, low mooring tensions in terms of the device motion, and our ability to be able to adapt the device to suit different wave climates. We have a long association, I guess, with research, and in particular with University College Cork, with whom we've worked closely over the years. I suppose we have always sought to de-risk the project in terms of the development curve. We have always sought to take smaller steps rather than big steps in terms of our development model. And this is a good summary of what we've tried to do. This is the very early stage first prototype device, a 1:50 scale device being tested in the wave tank in the Hydraulic Maritime and Research Centre in UCC. That gave us the confidence to take it to the next step, which was this guy, which is again looking a little bit more like what the finished product is going to be. This was a 1:15 scale device, tested down in Nantes. And again, this gave us a very important validation in terms of the confidence that we needed to take from these test programs to be able to continue investing and step it up to the quarter-scale device that we deployed off Galway Bay in winter of 2006. I'm going to show you just a quick montage of pictures here to do with the construction of the device. We are very proud to be an Irish company, very proud to be a Cork company. We constructed our quarter-scale device in the shipyard in Cork. We did our sea trials in Cork Harbour. We then towed our device, Christmas week in fact of 2006, we towed our device to Galway. This is the construction montage. Again, you will see even though it's a quarter-scale device, it is a big piece of kit. We built it with marine-grade steel. One of the things that I found interesting from PJ's presentation is the increasing prominence of composites in terms of their ability to provide companies like ours with alternative material as we look to drive costs down, as we look to economies of scale, and as we look to, I suppose, extend the life of these devices over time. And of course, that all feeds into the financial model. And commercially, the financial model has to make sense. Commercially, the financial model has to provide a return on investment. And here we see again, just as we deployed in Cork Harbour, you can get a sense of the finished product and its scale in terms of, that's Mike Whelan, our operations director on the device. So we deployed to Galway. We were very uncertain as to what we were likely to experience in Galway. The quarter-scale Atlantic sea conditions were ideally suited for us in terms of what we knew our full-scale device was likely to be operating in. Within a week of going on site, we had experienced an 8-metre wave occurrence hitting the device, which, although somewhat frightening at the time, nevertheless we needed that proof. We needed to put the device through that robust and rigorous test program, and we could only do that in an offshore environment. We have found that all of the model testing and all of the computer 3D analysis that we might do from shore really amounts for very little when we move into this very harsh, unpredictable environment that is the open ocean. The interesting thing that we found from the 3-scale test that we did, as you can see here on this model, is that they have broadly followed a similar pattern in terms of their performance. There have been some minor tweaks along the way, but generally speaking, we are now at a point where we are reasonably predictable in terms of the performance. One of the things that we have continued to try to do is to maintain a parallel development plan. For example, the quarter-scale device, when it finished its testing 2.5 years after going offshore, one of the interesting things for us then is we began work with Chorus, a collaboration research project through UCC and involving many European partners, where they were looking to develop alternative turbine technology, and we were quite happy to provide our platform as a base for that to be used. A couple of interesting things: we had webcams installed for the first time on the and we had some moving, and again you can see this gives you a sense of the type of motion that we had offshore. Again, this is the turbine. The initial turbine that we installed during our own test program was a Wells turbine, which was constructed and designed through Queen's and constructed in Cork. It was more of an impulse type turbine that was developed over the course of the Chorus project. Again, those results were quite interesting for us. This is a view from within the plenum chamber. So this was a very interesting view for us to get, one that we'd not seen before, where we can see the water motion. And again, I suppose you saw it in the animation. Here again, you see it in real life. We've always looked to try and add strategic partners. One of the great challenges that anybody in this sector will face, illustrated unfortunately by Wavebob's unfortunate liquidation, one which we regret. They were great friends of ours over the years, is the importance of having good, strong strategic partners. Dresser-Rand are one of those strategic partners for us. We are device developers, we are not turbine developers. So we have partnered with world-leading turbine developers, Dresser-Rand, who will work with us on the development of the turbine technology as we move forward. One of the interesting things that you'll see, I'll show you some quick snapshots in the association presentation when I have some slides to follow this, is that if we're to get the jobs out of this, and Denmark is the great model upon which to base this on, but if we're to get real meaningful jobs, job creation, indigenous wealth creation from this, we have to focus on manufacturing. If we don't capture the manufacturing in this country, there's a real danger that we lose the job value that can arise from it. If we do get the manufacturing, however, we can certainly look at about 8 jobs per megawatt installed. I've given you a breakdown there, and you can see that certainly manufacturing favours very much the commercial model in terms of making this work. Where are we at now in 2012? Having concluded our quarter-scale test device, we were selected by Wave Hub in Cornwall to occupy the UK test site there. We're currently working with Wave Hub now with a view towards construction, design, construction and deployment of that next scale device, which will take place at a date yet to be determined, but certainly over the forthcoming 18 to 24 months. Those of you who are familiar with Wave Hub will be familiar that they have a very strong coherent infrastructure in place to allow for devices such as ours to be grid connected and to be able to deliver power to the network via the subsea cable that has been installed. For us, it is the natural next step as we move towards full commercialisation. One of the things that you will find with every Wave developer, and I suppose I was intrigued by a question that Jeremy Galt of CMRC asked yesterday, you know, is it politics, is it investment, is it technology? And I think probably it's a little bit of all of those points. You need the political will in order to be able to create an environment which supports the development of technology. However, you need technology to step up to the plate and deliver actually something that does what it says on the box. And in doing so, the sum total of all of that will be to encourage investment, will be to move us closer towards achieving the sort of targets that we want to achieve. One of the things that I suppose I look back on with a wry smile is that if you go back some years, and we heard Mike talk yesterday about the 1,500 megawatt target by 2020, it's not that long ago we had a 75 megawatt target for 2012 and a 500 megawatt target for 2020. And we didn't come close to hitting the 2012 target, and that was quite evident early on. I would have a concern as to whether we're likely to hit a 500 megawatt target for 2020, never mind a 1,500 target. Very quickly, MRIA, and I'll fly through this, I'm conscious of time. MRIA was brought together probably 5 years ago now in response to the need to be able to create one coordinated reference point for industry. By industry, I include research, universities, industry, and the stakeholders from within state. So within that, it has grown from very small beginnings, chaired by Peter Coyle, who does a fantastic job for all of the members, from manufacturers, developers, supply chain, research, focused very much as an all-Ireland body, focused very much on wave and tidal, and very much on looking to try and solve some of the problems that we're confronted with, which individual companies can be difficult to solve. However, as an association, we can achieve what we need to achieve. Again, just running quickly through, you'll be familiar with some of these things, how low down the pecking order renewables is, but again, this is all about the opportunity. Ireland's position off the west coast, we have 4 times our national energy requirements sitting off the west coast. We should be a net exporter of energy rather than a net importer. Again, we have our test site in Belmullet, our Galway Bay test site, and IMERC and the Beaufort Laboratory in Cork being developed together with the Queen's and CGen collaboration in Strandford Lough. Mike, I'm going to fly through this, Mike. I'm just again mindful of, from Ireland's point of view, what do we want to get? It's about the job creation again. It's about the wealth creation. 2,000 jobs by 2020, 69,000 by 2030. But what do we do to make that happen? And it's not just about creating the environment, well-intentioned policy. It's about actually having a coordinated plan that involves world-leading technology. And the one thing that Ireland is outstanding at, it is absolutely, truly great at developing and encouraging a world-leading research environment. Now, it's crystallising that wonderful research, which in the first instance needs to be relevant, and in the second instance needs to have viable commercial potential. And how do we do that? Scotland is a good example, and we need to be careful here in Ireland because Scotland is very much stealing our thunder. and they're doing it very well. They have common cause from the top down. They know exactly what they want to achieve, and they know exactly how they wish to go about it. And they are very focused and very galvanised in terms of how they wish to do that. And I think that phrase that Peter has used in the past, a lesser resource than Ireland but greater ambition, perhaps. But there's our challenge. Danish experience, I spoke about it earlier. Turnover of 6.7 billion, but look at what they export. 80% of the equipment exported, representing 8.5% of Denmark's total exports, and employing over 24,000 people. Now, there's a reasonable expectation in terms of what Ireland should seek to try and aspire to it we can. Again, very quickly, you may be familiar with government policy and investment, but it's very much about harnessing the wealth, about investment. And if you look at the investment, both at laboratory, the Atlantic Marine Energy Test Site up in Balmullet, Science Foundation Ireland. Interestingly, Dr. Mark Ferguson, the new head of Science Foundation Ireland, is on record as saying that for projects which are more likely to be funded by SFI going forward will be those projects which are more likely to deliver a greater return on the investment by SFI. So there is a change, and there is a change taking place which we must all respond to. Finally, on a consultation, again, foreshore licences, legislation, etc., etc. All of these issues need to be dealt with. We need to deal with them more quickly than we are currently doing so. Again, the marine area, a single regime out to the 200 exclusive economic zone, a one-stop shop. Again, Scotland being held up as quite a good benchmark in terms of how to do this quite well. Next steps needed. We need to do it. We need to do what we're doing. We probably need to do it faster. And I think, again, our failure to hit the 75 megawatt by 2012 is probably a good example of how we need to shift focus and attention into different areas. The offshore renewable action plan for Northern Ireland, again, those targets are well established at this stage, and equally our own offshore renewable energy development plan, the consultation is complete. Government decision by year end and maps out the course to 2030, but it's where we go after that. Finally, if we can achieve everything that we wish to achieve, if we can achieve these ambitions, the national prize for the country as a whole is substantial. Ocean Energy, as one small company in this big chain of activity, is endeavouring to do its bit, and I think we're certainly moving in the right direction. Thank you.